Good morning. Let's take a look at set notation and different number sets. Set notation either uses braces around a list of the elements or members of a set, or around a description of the set. Braces are these curly figures, and you have to have one at the beginning and one at the end. A list would literally be a list of either elements or members of the set, such as the set containing the numbers 1, 2, and 3. Sometimes we may have an infinite set. With an infinite set, we can use the 3 dots, meaning etc., to continue on in the same pattern. So this would be the set of the numbers 1, 2, 3 forever. That the ... tells us that it also continues on in the same pattern. So the pattern would be to count by ones. So it would also contain 4, 5, 6, on and on forever. Sometimes we can shortcut a list by using the ... and then giving an endpoint. So this would be the set of numbers 1 through 100, whereas this would be the set of the numbers 1 through 1,000, again, counting by ones. These sets don't include any numbers that have any fractions in them. What if we have a set that we cannot describe numerically, and we also cannot list all of the elements? For instance, this set would contain everything that is a mammal. Now, we read this as, when we see the brace, we say the set, or possibly the set of. When you see the colon here, these 2 dots, what's in front of the colon, what comes before that, tells us what is representing each element of the set. So we would read this first part as the set of X. We read this colon as such that X is a mammal. So this part would be either a list or a description of what the elements are. Sometimes instead of the colon, they'll use a slash. So you might see this exact same set written with this vertical slash instead of the colon. It's purely the preference of the author. It doesn't make any difference. Either one is completely acceptable. In a case in your assignments where you need to put something like this, it'll probably already have this part, and then you just have to enter this part. And since there would be different ways to describe things, generally, any problem where it's going to use a description, you can expect it to be a multiple choice question. It's very important, if we're going to use a definition, that we use a very clear definition so that anyone can reasonably determine whether anything is an element of the set or not. What if we have a set that consists of X such that X is a person? I think most people would be able to determine whether any particular thing is a person or not. Is your friend a person? I would hope so. Is a rock a person? I don't think so. But what if you put adjectives in there, when you start putting adjectives and adverbs in there, sometimes it actually becomes less clear. Instead of narrowing it down, now it's like, well, depends. For instance, what if Y is in the set where Y is a nice person? Does everybody agree on who's nice and who isn't? Maybe everybody would agree that certain people are nice and everybody would agree that certain people aren't nice, but then there's going to be a lot of variation in there. So whereas the first one would probably be considered by most people to be a well-defined set, the second one actually becomes much less well-defined. Now what happens when we start talking about sets of numbers? The set of numbers that you learned when you were learning to count is called the set of counting numbers. It's also called the set of natural numbers, I guess because they come naturally to everybody. They generally use a capital N to represent this set of numbers, and it consists of the numbers 1, 2, 3, etc. 1, 2, 3, 4, 5, 6, 7, 8, 9, forever. The set of whole numbers, designated with a W, is simply the set of counting numbers with 0 added to that. So there is only one more number in the set of whole numbers than there is in the set of natural numbers. The set of integers, which this particular book uses I to represent, but is more commonly used as a Z. Don't ask me why. The set of integers includes all of the natural numbers, the opposites of the natural numbers. So the opposite of 1 is -1. And by the way, the opposite of -1 is 1. Opposites are like twins, they have to come in pairs. So it's got the natural numbers, the opposites of the natural numbers, and the number 0. 0 is considered fairly neutral. It doesn't have an opposite. There is no -0. Now, the set of rational numbers is the set of any number that can be written as a fraction. A fraction with an integer for the numerator and an integer for the denominator. And they use Q, not just off the wall, but Q stands for quotient. Now, there's no way to list all the possible fractions. There's not even a way to list all of the fractions that fall between 1 and 2, or between 0 and 1. There's an infinite number of fractions between 0 and 1. 1/2, 1/3, 1/4, 1/5, not even going into 2/3, 3/4. So the only possible way to list the rational numbers is to list it as a quotient or a ratio. So we could make this the set of numbers x over y such that x and y are integers. That's a description that would do it and also be well defined. Now, the set of irrational numbers includes numbers like the square root of 2, the square root of 3, not the square root of 4, because that's 2, which is an integer and a whole number and a natural number. But we could say the square root of 5. We could also go into cube roots, the cube roots of anything that won't reduce to an integer or a rational number, and fourth and fifth and sixth roots. It also has some other numbers that occur naturally, such as the number pi. but there's no way to even describe all the possibilities beyond saying that the set of irrational numbers are simply all of the numbers that aren't rational numbers. Now, this book doesn't go into irrational numbers. Therefore, there's no reason for them not to use I to represent integers. But most books actually do use I to represent the set of irrational numbers. You're not going to see it in our current book. But irrational numbers would be the set of x's such that x is not a rational number. The set of real numbers is what happens when we combine the rational and the irrational numbers. And then I always really wondered why they would bother to call anything a real number. But there is a set of numbers called imaginary numbers. We're not going to get into that right now, but that is why they actually call something a real number. Also, something that I'd like to point out at this point, notice that we can use the ... at the end of a set of numbers to indicate that it goes forever getting larger. We can use it at the beginning of a set of numbers to show that it goes infinitely in that direction. We can use it in the middle of a set of numbers. Already we talked about that. Do not in English class use ... or etc. randomly. If you go in and you write an English essay and you attempt to use etc. in a sentence, they're going to burn you for it. However, in mathematics, we use a lot of infinite sets and a lot of sets that are very large. So we actually get away with this much better in math than we do in English. All right, so that is set notation, how to write a set, and different sets of numbers that you're going to need to know. Hope you enjoyed this, and I will talk to you later. Bye.